Hello everyone, welcome back to Vernier Calipers series. Now we solve few problems from previous JEE papers. Let us go to the first question. A vernier caliper has 20 vernier scale divisions equal to 19 main scale divisions. One main scale division is 1 mm. If the main scale reads 1.2 cm and 13th VHD coincides, find the final measurement. In the first sentence, it is given that 20 vernier scale divisions, okay, that is the principle. 20 VHD is equal to 19 MSD, main scale division. And one main scale division is given, that is 1 MSD is equal to 1 mm. So from this, we can find out what is 1 VHD. That is 1 VHD that is equal to 19 by 20 MSD. And since we know the value of MSD, so that is 19 by 20 into 1 mm, that is 0.95 millimeter. Now we find out the least count. Okay, least count, that is equal to 1 MSD minus 1 VHD. So that is 1 minus 0.95 millimeters, that is equal to 0.05 millimeters. Next, the main scale reads 1.2 centimeter, that is main scale reading, that is equal to 1.2 centimeters. And the vernier coinciding division, say VCD, that is equal to 13. Now find the final measurement, that is say total reading. So I write it as total reading, that is TR is equal to MSR plus VCD into LC. Okay, so that is equal to MSR 1.2 centimeters, that is 12 mm, plus VCD 13 into the least count 0.05. That is equal to 12 plus 0.65. So 12.65 is the final reading, that is in millimeters. The next question is, the diameter of a spherical bob is measured using a vernier calipers. 9 divisions of the main scale in the vernier calipers are equal to 10 divisions of the vernier scale. One main scale division is 1 mm. So here two informations are given. The first one is the Vernier Calipers principle, that is 10 VHD is equal to 9 MSD. And next one is the value of 1 MSD is also given, that is 1 MSD is equal to 1 mm. Okay, since 10 VHD is equal to 9 MSD and 1 MSD is equal to 1 mm, then it is a standard vernier calipers. Therefore, the least count is 0.1 millimeter. Now we go to the next part. The main scale reading is 10 millimeters, that is MSR is 10 millimeters. And the vernier coinciding division, that is 8th division of the vernier scale, was found to coincide exactly with the one of the main scale division. Therefore, VCD is 8. Now, if the given vernier calipers has zero error of 0.04 centimeter, that is a zero error, say ZE is equal to 0.04. That since it is a positive, okay, we need to put plus 0.04 centimeter or plus 0.4 millimeter. Then now we find out the total reading. Okay, total reading. The total reading gives the diameter of the spherical bob. Let's say it is D. Diameter is denoted by D. Therefore, that is equal to main scale reading, that is 10, plus the vernier coinciding division, that is 8, into the least count, that is 0.1. Therefore, it is 10.8 millimeters. So first of all, we apply the zero error here. Since the zero error is a positive, then the corrected reading, say it is CR, that is equal to 10.8 minus 0.4. The correction will be negative here. Okay, therefore, the reading is 10.4 millimeters. Now we find the radius, say R, that is equal to diameter by 2. Okay, therefore, diameter is 10.4 divided by 2. Therefore, it will be 5.2 millimeters. And this can also be written in centimeters, that is 0.52 centimeters. But here it is given, it should be mentioned in terms of into 10 power minus 2 centimeters. So therefore, we just multiply and divide with 10 power 2. That is 0.52 into 10 power 2 and divide. Therefore, that is 10 power minus 2. That will be in terms of centimeters, because here 10 power 2 into 10 power minus 2, this value gives 1. Okay. Therefore, now we need to multiply these two. We need to combine these two. That is 0.52 into 10 power 2, that is 52. Okay, 52 into 10 power minus 2 centimeters. Therefore, the value we need to write here is 52. The next problem, the smallest division on the main scale of a Vernier calipers is 0.1 centimeter. Okay, that is 1 MSD is 0.1 centimeter or 1 millimeter. 1 MSD is 0.1 centimeter or 1 millimeter. 10 divisions of the Vernier scale correspond to 9 divisions of the main scale, that is 10 VSD is equal to 9 MSD. So from this we can find out what is 1 VSD. Okay, 1 VSD is equal to 9 by 10 MSD. So 1 MSD is equal to 1 mm. Therefore, it is 0.9 mm is the value of 1 VSD. Therefore, we can find out the least count from these values, that is least count is equal to 1 MSD minus 1 VSD, that is 1 mm minus 0.9 mm, that is 0.1 millimeter is the least count of the given Vernier calipers. The next step, the figure below on the left shows the reading of this calipers with no gap between its two jaws. That means when the two jaws are in contact with each other, okay, the reading, it is shown by the left figure. Okay, this one, the first figure. Okay, this is the first figure. So when the two jaws are in contact, so you can see that the zero line on the Vernier scale is on the left side of the zero line of the main scale. Therefore, this device is having a negative zero error, that is negative zero error, say it is minus ZE. Okay, that is equal to, we need to find out the negative zero error. So for finding negative zero error, what we need to do? We need to take the Vernier coinciding division. So here it is a 6th division, and we need to subtract from the total number of divisions. Total number of divisions, that is 10. So it is 10 minus 6 into the least count, that is 0.1. And since the error is negative, we need to put negative sign, minus 4 into 0.1, that is 0.4 millimeter. Now, the next step is the figure on the right, just say second one. The second figure shows the reading with a solid sphere held between the jaws. The correct diameter of the sphere is, when the sphere is fixed between the two jaws, okay, the reading is shown by the right side figure. So here you can see that from the second figure, we note down the values of the main scale reading, that is MSR that is equal to 3.1 centimeter or 31 millimeter, and the Vernier coinciding division, that is VCD, the first line is coinciding, therefore VCD is equal to 1. Now we find out the total reading, that is the diameter of the sphere. The total reading, just say TR, that is the diameter, say D, that is equal to MSR 31 plus VCD, that is 1, into the least count, that is 0.1. Okay, that is equal to 31.1 millimeter. Now here the negative zero error is minus 0.4 mm. Therefore the correction will be positive, that is plus 0.4 mm. Now we find out the corrected reading. Say it is CR, that is corrected reading, is equal to 31.1 plus 0.4, that is equal to 31.5 millimeters. Now in centimeters, that is divided by 10. 31.5 divided by 10, that is 3.15 centimeter. So from the given options, the C is the correct option. Next question. In a Vernier calipers, each centimeter on the main scale is divided into 20 equal parts. If 10th Vernier scale division coincides with 9th main scale division, then the value of the Vernier constant will be. That means we need to find out the least count of the Vernier calipers. Least count. So here each centimeter on the main scale is divided into 20 equal parts. Therefore, one main scale division, 1 MSD, is equal to 1 centimeter divided by 20, that is 0.05 centimeter or 0.5 millimeter. Okay, what else is given here? 10th Vernier scale division. 10th division is coinciding with the 9th division on the main scale. Therefore, 10 Vernier scale divisions is equal to 9 main scale divisions. So from this we can find out the value of 1 VSD, 1 Vernier scale division, that is equal to 9 by 10 main scale division. So since we know the value of main scale division, we can substitute here, that is 9 by 10 into main scale division, that is 0.5. Okay, 9 into 0.5, that is 4.5, divided by 10, that is 0.45 millimeter. Okay, now we have the values of 1 MSD and 1 VSD. Therefore, we can find out the least count. That is least count. The least count is equal to 1 main scale division minus 1 Vernier scale division. Okay, that is equal to 0.5 minus 0.45. Okay, that is equal to 0.05 millimeter. Okay, so what we need to do, we need to find out the same value in terms of into 10 power minus 2. Okay, therefore you multiply and divide with 10 power 2. So it will be 10 power 2 divided by 10 power 2. So if it comes to numerator, it will be 10 power minus 2 millimeter. So this should be taken out. And so if you multiply 10 power 2 with the 0.05, so it will be 5 into 10 power minus 2 millimeter. So this is one way. Otherwise, you can also find out, okay, least count, that is LC is equal to 1 main scale division, that is 0.5 millimeter divided by the number of divisions on the Vernier scale, that is 10. That is 0.05 0.05 millimeter or 5 into 10 power minus 2 millimeter. Now we go to the next problem. The diameter of a cylinder is measured using a vernier calipers with no zero error. It is found that the zero of the vernier scale lies between 5.10 and 5.15 centimeters. Okay. That means these two lines are just side by side lines. Therefore, the length between these two lines gives the one main scale division. So therefore, we can find out the one main scale division here. 1 MHD, that is equal to 5.15 minus 5.10 centimeters. Okay, so it will be how much? 0.05 centimeters, or in millimeters it is 0.5 millimeters. Okay. And the next line, the vernier scale has 50 divisions equivalent to 2.45. So 50 vernier scale divisions, 50 VSD, that is equal to 2.45 centimeters. So from this we can find out what is 1 VSD. 1 VSD is equal to 2.45 divided by 50. That gives 0.049 centimeters or 0.49 millimeters. Next we see, so here, so since we know what is 1 MHD and the number of vernier scale divisions 50, I think we can also find out the least count the other way, that is least count is equal to 1 MHD divided by the number of vernier scale divisions, that is 50. So that is equal to 0.5 divided by 50. So that is equal to 0.01 millimeters. So if you find out the normal way, that is least count is equal to 1 MHD minus 1 VSD, then it will be 0.5 minus 0.49, that is equal to 0.01 millimeters. I am showing both the methods to understand the least count formula. So the next line, the 24th division on the vernier scale exactly coincides with one of the main scale divisions. That is, the vernier coinciding division VCD is equal to 24. The diameter of the cylinder is. So what is the MSR here? The MSR is given in the second line itself, that is the zero of the vernier scale lies between 5.10 and 5.15 centimeters. That means the main scale reading here is MSR is equal to the reading just before the zero line of the vernier scale, that is 5.10 centimeter. To find out the diameter, we just need to add main scale reading and vernier scale reading. That is the total reading, that is the diameter, just say D, that is equal to the main scale reading, that is 5.10, plus the vernier scale reading, that is VCD into LC, that is VCD is 24, and least count is in terms of millimeters. We need to convert it into centimeters, that is 0.001. Therefore, the diameter is equal to 5.10 plus 0.024. Therefore, that is 5.124 centimeters. So this is the diameter of the cylinder. Next problem. A vernier calipers has 1 millimeter marks on the main scale, that is 1 MHD is equal to 1 mm. 1 MHD is equal to 1 millimeter. it has 20 equal divisions on the vernier scale, which match with 16 main scale divisions. That is 20 PSD is equal to 16 MSD. Now for this vernier calipers, the least count is, what is the least count here? We need to find out the least count is how much. So here one main scale division, that is 1 mm, and there are 20 vernier scale divisions. So we have the formula 1 main scale division by 20 vernier scale divisions. Can we use that formula? No, because okay, 1 main scale division divided by 20 vernier scale division is the simplified formula for the vernier calipers, which is having the principle, or which is following the principle, that is n VSD is equal to n minus 1 MSD. But if you see here, n VSD is equal to n minus 4 MSD. So therefore, we cannot use the formula, that is 1 MSD by number of VSD. So here we follow the standard formula, that is least count is equal to 1 MSD minus 1 VSD. So for that, okay, we need to find out what is the VSD value. So 1 VSD is equal to 16 by 20 MSD. Okay, so 16 by 20 MSD value is 1 mm. So therefore 16 by 20 value, that is 0.8 millimeter. So now the least count that is equal to 1 main scale division minus 1 vernier scale division, that is equal to 1 minus 0.8, that is equal to 0.2 millimeters. The next problem, the edge of a cube is measured using a vernier calipers. 9 divisions of the main scale is equal to 10 divisions of the vernier scale, and 1 main scale division is 1 mm. So here everything is given, that is 1 main scale division is 1 mm, 10 VSD is equal to 9 MSD. So therefore the least count will be 0.1 mm. Next one, the main scale division reading, that is 10, and 1 division of the vernier scale was found to be coinciding with the main scale. The mass of the cube is 2.736 grams, and calculate the density in gram per centimeter. So here the edge of a cube is measured by using a vernier calipers, and it is having the main scale division value, that is 1 MSD is equal to 1 mm, and the number of vernier scale divisions are 10. Okay, therefore capital N is equal to 10, and since it is following the principle 10 VSD is equal to 9 MSD, the least count can be calculated directly with the simplified formula, that is 1 MSD divided by the number of vernier scale divisions, that is 1 by 10, that is 0.1 millimeter. And the main scale reading, that is 10 mm. So MSR is 10 mm, that is equal to 1 centimeter, and the division on the vernier scale, that is coinciding with the one of the main scale division, that is VCD is equal to 1. The total reading, that is the side of the cube, that is equal to the main scale reading, that is MSR, plus the vernier scale reading, that is BCD, into the least count. So here the MSR is 1 centimeter plus VCD is, that is 1, into the least count 0.01, that is equal to how much? 1.01 centimeters. This is the side of the cube. Therefore the volume of the cube, that is equal to side cube side cube, that is equal to 1.01 whole cube. That is equal to 1.030301. Now the density is equal to mass per volume. So the mass is given here, that is mass is 2.736 divided by the volume, that is 1.030301, that is equal to 2.8189 gram per centimeter cube.